take a look. RenderDoc, what does it have? It has timeline on the top, event browser on the left, and some previewers in the middle. In simple terms, that's it. Timeline means how the given frame is rendered step by step. So for example, first the background, then the objects, then some lighting on top of the objects. You will see that later when I do a capture. Event browser is the same as timeline but named. Events have some names. Sometimes easy to decipher, sometimes not. And the middle thing is basically the content of the given step in the frame. Okay? So let me hydrate and let's jump into how to get a frame from Unreal. But before we get a frame from Unreal, let's get a frame from a game. So take a look. This is not Unreal workflow yet. This is standard workflow for a standalone application. You go to File in RenderDoc. And by the way, where to get it? Render.org, builds, get RenderDoc. Here. You just download it, it's open source. File, launch application. Here. Click it. It asks for executable path for the exe and for the working directory, which is usually the thing that exe is located in. You can provide extra arguments if you know them. And now capture options. Very often the exe is just a launcher. GTA launcher exe, right? The game itself is elsewhere. So in that case, you have to press capture child processes here. But you will know. You will know, and I will tell you in a second how. Press auto start here. Allow full screen as you wish. I usually disable that. All the other things are for later if anything goes wrong. And that's it. Exe directory. On the bottom right, launch. And now it launched the game. But there's one more unusual addition. Take a look at the top. Here we have capturing D3D, frame number, and the shortcut to capture, F12 or print screen by default. So here's the game. Start. Disable music. Okay. Here's the game. Here's the menu. Let's start the game itself. Guinnessa versus Zelda. Here we have Bad North, a typical scenario, tutorial scenario. As you can see, frames are progressing, okay? So let me try what it says, F12. Small hitch and captured frame number 3304. I'm gonna close the game. And now in my RenderDoc, a new thing appeared. Right there is a frame. There is a frame. It shows the entire frame. We're in texture viewer. It shows the result of the last step in the frame. So now, what is this thing on the left? Now what's on the top? On the top, as I said, we have timeline. Typically it's zoomed in, so let's zoom out. Oh no, it shows everything. Right. I can expand that and show some steps. It's unclear yet what they are. It's named Color Pass 1. Selfoxerot asks, does RenderDoc work with Nanite and Lumen? We can figure out. It's a great test, actually. Let's do it. Let's do it, and let's see how Nanite is rendered. Ashkento asks Mac alternatives to RenderDoc. I'm not sure because I haven't developed on Mac. Yeah, there's Linux, there's Win. That's a good question actually. I think Metal should have its own frame debugger. Let's check. Debugging tools. Viewing the GPU workload with Metal debugger. Okay, there's some Metal debugger in Xcode, maybe that. Looks similar. So I'd say this. Metal debugger in Xcode. Okay. So here we have the frame. This is the result of the last step. Step number 530. So this is a very simple game actually. I mean, its rendering is very nicely minimalistic as the aesthetics. Okay. So now what's this? 2 color passes. First color pass results in that image, surprisingly flipped. And the second color pass looks like the same thing, just flipped. I don't know what's more, maybe UI? Probably. Oh yes, take a look. This one has the inverted image properly, and on the top it has this click and drag to rotate the camera. This one doesn't have it. So basically in RenderDoc, we click on steps to see the result, but some steps won't have just the color result, right? For example, this is a normal map rendering pass or something. So then we'll have to dig deeper. Let's go to color pass 1, which ends up with this image. Here you have first step, clear render target view. It clears the background with some color. Color is shown there on the bottom. You can also right click a pixel, and on the right bottom you have pixel context. I will explain that later. But basically that right click throws a single pixel. So on the bottom we see its RGBA values. 0.58, 0.72, 0.74, 1. Okay? The type of that color is R16, so 16 bits, more than typical. Typically you have 8 bits for everything, 16 bits for R, 16 bits for G, 16 bits for B, and 16 alpha, typeless. There's also the resolution mentioned. So clicking through them, I can see that this was drawn first, whatever that is. When I hover the mouse, you can see how the color information changes, right? Clicking further. Now I have some terrain with some shadows. Okay. The soft ocean around. A hut. Islands? No, another hut. What's this? The outline. The external outline. Clicking further. More shadows. Oh, waves. Okay, so let's see how the waves look like. Here they are. Or maybe no. Let's begin with the hut. Here it is. A hut was added. So now, how do we know how the mesh look like? Here we are in texture viewer. But it shows us the image, the temp buffer 2. If you go to pipeline state, you will see more stuff. You will see all the steps. But this is, let's say, data, just raw data. It says that it has some buffers inside, but we don't care about it too much. So pipeline state doesn't interest us yet. We rather go to mesh viewer. And in this mesh viewer, I have the mesh of the hut. Left click drag allows me to rotate that. Solid shading, flat shaded. Here it is. A model captured from the actual published commercial game. Right? Here you can inspect the modeling. how funny the window looks like. Very clever. This is it. This is the HUD. Secondary shows us UVs most probably, but I'm not so sure. Okay, so this is vertex shader input. We are a bit lucky because this game is, as I said, simple in its rendering, so it doesn't do any trickery to these meshes. For example, in many games you will see that the meshes are stretched to a unit cube, 1 by 1 by 1, so artificially stretched to better preserve the positions with more precision. Now VS out, what is VS out? So this is what came into the vertex shader, and VS out is what happened after the vertex shader. So remember, vertex shader is not only doing animation or something to vertices or the UVs, it's also doing camera projection and perspective. So this is our texture viewer of this. Now if you go into mesh viewer into VS out, you will see some similarity. This is the same. Okay. Here you cannot, you can actually fly with WSAD, but remember this is from camera perspective, right? So VS out. Same HUD, same view. This is what happened after vertex shader. If I were to rotate it, you can see how flat it is, because this is the final transform of the vertices. So yeah, using this in your game, you can see if, for example, some stuff is rendered where it shouldn't be. Maybe you're missing some occluders. You can also check. I think I don't have. I don't know if there is a way to do this in RenderDoc, but there's definitely a way to do it in console-based tools that are very similar. For example, Pix from Microsoft, PIX, that you can sometimes measure how much time it took to render the given step. But here, this is already useful to debug stuff, especially if you are not sure what's there. You, for example, play a game and there's some weird black object, right? Some weird black object. You don't know what it is. So here you can go into VS in and at least check what object this is. Okay, so then it draws some other stuff. Some HUDs. Here are probably the waves. Let's see. Yep, these are the waves. This is how they look like. Let's check the UVs. Huh. Or maybe this is not UVs, but vertex color. I'm not sure. This is something. But basically, yeah, there's some info looking like that in these waves. What's this? What is the pink thing? Pink thing. It's also around here. I'm not sure. Anyway, yeah, this is how waves were done. Here are the camera controls. And GS DS out is only for tessellation and stuff like that. Geometry shader, basically. Right? Now, what more can we have? We have the geometry of the waves. Cool. What about the texture? The texture. Let's go to texture viewer. Click on inputs tab here. And now you can see that when I change the step, this is probably the, oh, this is the HUD. Then in texture viewer, I see textures used in drawing that thing. Maybe not used directly, but bounded during that step. So here's some funny texture. Very small. Very, very small. Of something related to that HUD. And one more thing. When you are looking at the output here, you can overlay it with highlight draw call. So once again, it's probably the shadow, because you can see not much has changed, but yet when I highlight draw call, it's there, fitting the shadow, right? So this is this. Let's find the HUD itself. Yeah, here. Highlight draw call. Exactly, right? This appears. I mean, this HUD appears, and then here it is. Wireframe mesh, wireframe of that draw. And this also shows you what do people mean when they say you have too many draw calls in your scene. So as you can see, combination of shader parameters, and mesh, all this is a draw, because a draw is geometry plus the shader setup. So in the inputs you have, for example, textures, right? Somewhere there you also have a constant buffer, which is shader parameters, usually. So that's why you have more draw calls when you do separate materials, because typically engine merges things that have the same material and geometry for speed, because every such draw has to be issued by the CPU. CPU tells the GPU to reconfigure the state, so to change the mesh that's used and to bind a different set of textures. So maybe surprisingly to many of you, at least it was a surprise for me a few years back, there's one global state when you draw stuff on the GPU. This is more complicated than DirectX 12 and Vulkan. You have some command lists, but basically a draw is a slow thing because it has to be issued by the CPU through the driver on Windows to the GPU, and then it draws and updates. So yeah, if you could merge stuff into one draw, you already gain a lot, because GPU is very fast at drawing things, but the driver and the single threaded driver can be a bottleneck. So about that, on my channel I have a video about instancing. Oh, here it is. Instancing, this one. So there I explain here how you can use instance static mesh in Unreal to draw an amazing number of objects, actually clones, using just one draw, a single draw, because you can just pass a set of positions to the GPU and tell it to draw this object many, many times, let's say for free. Not for free because you have the shading of the triangles and stuff, but still without additional draw calls. And about that also, on my Patreon, patreon.com, techart8, here, you have a post, where is it? About instances. Yeah, material tricks for instancing, that's one of them. It explains how you can combine into one draw call, but not have every mesh look the same. Actually, every mesh can have a different texture set. And then I expand upon this idea into a much more optimal shader in this post, blending materials a high performance way. So it's on Patreon, and it shows how to use UDIMs, virtual textures of a special kind, to maximize performance and yet use just one instance static mesh. So back to this. There's not many draws because there's not many objects. And look at this. All of those guys were drawn in one go. And this is what I mean. Many objects, one draw, because they're the same, right? Or cleverly done in the shader. See, here we have the textures used. So let's take a look. Texture 1. See? So you can basically grab resources from a game for learning purposes. And there on the top, you can preview individual channels. This is red. This is green. That looks funny, but nice. This is blue. Okay. And here, alpha. Yeah, alpha is there also. Now, on the top right, you have save selected texture, and you can save it to a format of choice. But remember that not every format can store every pixel format. So take a look at the bottom. R8, G8, B8 is typical 8-bit per channel. So most popular type. You can save it to everything. DDS is the most, let's say, compatible with custom formats in game engines. But if you just need 16-bit or 32, you can save HDR or EXR. So yeah, this is bed north analyzed in RenderDoc. Here we have, for example, this UI pass showing the possible buttons with alpha. Okay, so now to Unreal. Let's go back. How to use RenderDoc with Unreal? Of course, we could and usually should test in standalone game, not in editor. Editor is cluttered. Editor has its own draw cost for a ton of stuff. It's also drawn in 3D, let's say, a harder acceleration. So what you typically do is go here into platforms, Windows, package, project, in debug or development. Development is enough. Shipping is not enough because it strips too much stuff. So development and then package project. And we package this project and then we can open the exe in RenderDoc. However, there is one more way. Let's go to plugins. Let's type RenderDoc. Here it is, RenderDoc plugin, embedded into Unreal. It asks to restart, so let's do it. Ashkento says that models could be saved too. That models can be saved too. Let's go back to the HUD. Oh, mesh viewer. Yeah, here it is. Ah, here on top. Or no? No, it's CSV to bytes. But how to save some OBJ or something? Extension. Ashkento, can you share on Discord? Because here I have links disabled on Twitch. Settings. No. Where are the plugins? Extensions. Manage extensions. No extensions found. Browse them here. RenderDoc contrib. Okay. Okay, anyway, if you know where to find it, let know on Discord. Oh, with plugin. Okay, that's what I thought. Okay, so we enabled that RenderDoc plugin in Unreal. Now let's open a scene, for example. Instancing mats v2. This is what I mentioned. This is the latest post on Patreon. So now it added something. Should add it. Oh, right there. Top right of the viewport enabling that RenderDoc plugin added, capture the next frame and launch RenderDoc UI. Let's click it. Okay, it takes a while. Let's see what happens. It's there, loading the capture without packaging the project. But as you can see, it captured the entire Unreal editor. That's why I mean packaging the project may be better. So let's in the meantime package it. Platforms, Windows, package project. I have to set the default map to this map. So edit, project settings. This is important. Maps and modes. Game default map will be maps v2. Okay. Copy, paste. Okay, and now here, platforms, Windows package project. Let's go to drive W, Unreal temp project builds, which RenderDoc. Which one is today? 7. And select. Okay, it will package the project in the meantime. It's running. So let's go here. Captures collected is there. Texture is completely empty. Fit. Let's go to the end. Huh, here it is. Here is our scene. Canvas batched elements. Scene. Okay. Oh. Discarded image. There's a lot of stuff. I need to find the scene itself. Copy buffer, yeah, right. Scene. Pre-render. Submit commands. Oh no, just submitting. Base paths. Contains a skydome mesh. Okay, this hasn't drawn anything yet. Or maybe it's in a different resource. Yes, because take a look. Unreal is a deferred renderer, right? So you have Unreal here, color. But typically you have this, so base color rendered first with normals and with other stuff. And only based on this, lighting is done and applied on top like that. So here you can see this. The sky is empty yet, and it says your scene contains a skydome mesh with a sky material, but it does not cover that part of the screen. This, what you can see here, is actually real material used in UE5. But you can see the cutout of some objects in the spheres, or no, something. And here it tries to draw the floor, okay? As you can see, mTest grid floor, draw index instance. But it already draws here. Why doesn't it draw on top of these test shapes? That's because I have early Z enabled in that project. So depth of object is drawn first, and then it knows where to not waste computation time drawing stuff that won't be visible because it's occluded by other objects. So as you can see, it draws the floor. This is the color of the floor, but it draws it only when there were no objects in front, saving computation time. So here it is. Now, this is just base pass parallel of one thing. That's because all of the other objects will probably be nanite. Let's check. Nanite triangles. Actually, no. So let's go back and let's try to find these spheres where they could be. Oh, this is already lighting. Ah, here they are. Okay, so it's just the next object. So base path is the path that draws to the G buffer. What is G buffer? G buffer is the global texture, full screen texture that contains base color, roughness, metallic, normals, and stuff like this. Later used by deferred lighting. So here you can see it drawn the grid floor, and then it drawn this M instancing mats UDIM test shape 4. So there's this indirect draw indexed 29 times. So that's how many objects I have. So this is the instancing in working, because one mesh, as you can see, I will go into mesh viewer. There's one mesh, okay, but automatically drawn so many times, and as you can see, the texture is different. This texture is different for every object. So how is it possible? See the latest Patreon post to find out how I did this. But this is all one instance static mesh with nice transitions between full materials. Now, if I see the other gbuffer channels, like normals, here they are. Hey, Sophie Hefner, thanks for following. I remember using RenderDoc constantly when I was writing my own render. Perfect. Exactly, and I can't imagine work like this without a debugger like that, right? If you have any tips about it that I won't show, then of course feel free to say. I'm not a RenderDoc expert by any means. One eye says, just for information, for debugging you need to change some console variables to get the whole pipeline. So disable optimization of shaders and keep debug info. Okay, so let's go to here. I think this RenderDoc capture did it automatically, part of this, but as one eye says, typically you have to do R, filters, keep debug info 1, and also sometimes RenderDoc will just show garbage instead of interesting stuff when you have the standalone game and you capture that. So what do? When playing the game, you press, that's the game, you press tilde and enter profile GPU. Profile GPU will take a capture of your frame, do some analysis, but it doesn't matter. What matters is that by accident, or no, it's intentional, I know, but basically it's a side effect. It also enables full names of the steps in RenderDoc. So this is the same thing that one eye mentioned to do in the ini file, but just manual. But of course do it in the ini file to have it all the time. So we won't forget about that. Oh, by the way, this tilde profile GPU command gives you this. This is GPU visualizer. And I have a very nice video about that I still like on youtube.com, Deckard8. There is a graphics profiling playlist. My graphics profiling series. So I recommend that if you're interested in what I showed today. And there's built-in profiler about GPU visualizer. And much more. So here you can also see the scene, but also showing the timing. But never check it in editor. Check it in a standalone game. Because this is very, very ballpark when you do stuff in editor, which has a lot of overhead. But basically you can see how much it's spent on different stuff. Right? So here we have diffuse indirect, so lumen, post-processing, lumen scene lighting, so a lot of lumen in here. And very, very short base pass, very short. 0.3 milliseconds, it's nothing. Okay. So back to our RenderDoc. Here we have it. Grid floor, drone, then these objects drone. The textures bounded as inputs are virtual textures. So that's why they look so weird. Take a look. This is actually the same material I have there, but split into tiles. And I explain virtual textures and how they split stuff into tiles for optimization in the same video on Patreon. So yeah, where was it? Here. Blending materials in a high performance way. Patreon.com/Deckard8. This is a virtual textures and these are slices of that huge texture atlas. So interesting to see how it sees a virtual texture. And this is also another virtual texture, this time normal map. As you can see, it's different, doesn't have the same layout. Okay. Okay, sometimes you want to make things brighter or something, so you do this here. Just change the range. It will remap it to 0 to 1. Okay. Here it is. You can also do negative range. Like this. It will have more sense with an HDR texture. Okay, so that's it. That's RenderDoc. We know how to use it. Mesh viewer, as I shown you before. It's here. But you may have to click on not the main group, but the actual command, like indirect draw indexes. Because first command just prepares that stuff and then actually draws. Secondary. Right. Oh, and Sophie Hefner is the same person as Lilo. Nice. Okay. So having that, is there something else I wanted to show you? I show you the vertex shader. The textures. What else? I would like to show you the nanite, but let's have something nanite based. I'm gonna close that. Nope. Let's put in some nanite mesh. Stop it. Nanite tests. Okay, here's a great test. Let's put it here. 2 nanite based meshes, one with vertex color, another just heavily displaced. Okay, let's put some material on it. Some better material. Okay. Take a look. Compiles shader. Okay. It's there. And let's capture. It will take longer because there are more vertices this time. Yeah, as I said, longer. And let's find nanite and let's find lumen. Find lumen. Hey, here's the frame. Let's save it. Just in case. Where did it draw it? Scene. Compute lighting grid. Render finish. Oh yeah, perfect. Let's save it. Save, okay. So now, about Nanite. Let's first go back in time. We can actually use this. Expand it. Here you can see Nanite is drawn first. Then there's base pass. Then there's Lumen. So base pass. There's also Nanite base pass. Perfect. So base pass parallel. First draws the grid floor as before. Here. Highlight draw all. Then it draws the spheres. Right there. Wireframe mesh. Here they are. And output is, for example, the normal, right? No. But here you can see that the depths of Nanite objects were also drawn first. So the base pass didn't have to render behind Nanite objects because early Z is enabled in the project settings. So now Nanite base pass. How does this look like? First there's clearing of the Nanite buffer. Initialization of materials. Just a dispatch, so it's a compute. So we won't see it. Has anything changed? Not yet. Not yet. Initialize the materials. Classify the materials. Setting pipeline state. Sure, but we won't see anything. Nanite material resolve. Okay. Okay. When I right click on the pixel, I can see that its value is 32,769 and the background is 0. This is different. When I right click on that, it's 32,771. So let's enter a number like that. Let's start with a smaller one. Let's do 32,768, for example. And the last thing will be the same, but 80. Yeah. Actually less. 77. 67? No. 77. Right. I can do auto. No, it's bad. This was almost good. Yep. What was the number again? 769. So let's do 768. Yeah. And you can see the values are different. They are meaningless for the human, right? But it means this is how Nanite saves which material it is. It's, let's say, an HDR 16-bit per channel grayscale texture. And it has just a different number for different material. That way it knows which material is which. Then it does emit gbuffer. Here. It actually says Tecartate logo something something. Let's restore that. It's not. And it prepared the texture that's used in that shader as an input. This visibility buffer, smaller resolution, as you can see, this visibility buffer, probably, or maybe not. No, I'm not sure now. Maybe not. And here it is. It's drawn something. But how does this mesh look like for Nanite? Let's overlay it with wireframe mesh. This is how it looks like. So as you can see, Nanite is using quads of a fixed size, and then it resolves the rendering of the base pass within each quad like a mini viewport. Okay, rendering in tiles, but as you can see, there are no triangles spawned for places that are not covered by that object. So first, it tries to find out where it will have the squares to render. It spawns a little quad, so 2 triangles for each such tile, and then it draws on the GPU the given part of nanite rendering. So that's very interesting. Here it just finalizes that stuff. Is the normal map written to? Yes, it is. The same thing. We go there. As you can see, the wireframe is there. The draw area looks like that. So that's the actual mesh being drawn. A bunch of quads. And everything happens inside in the material. In the shader. And then it draws this. So that object, this object. Same thing when we look into it. Wireframe mesh. Yeah. Covering the part that the mesh is covering. Okay. And now how does this mesh input look like? Go to mesh viewer. That's the mesh. 2 triangles. A quad. Okay. Despite that we see this. And here somewhere we should also have the input mesh for this, but I'm not sure how is it stored. Probably we won't find it that easily. Executing direct. Here it draws, yes. But where does it take the stuff from? Should be here. No, begin event. Set constant buffer view. Sure. Oh, this is every resource possible. I don't know how to actually view this. But maybe it's unreadable because I will have to know the layout, yeah, of the data, the struct. So it doesn't matter. But basically, yeah, nanite is here. Drawn like this. So now let's go find lumen. Here's the sky path, drawing sky sphere. This is the sky box. And then after this, not normals, but color, final color is here. The sky is drawn like that. But there's no lighting yet, right? So that's why we should look for lumen. Oh, and also, if you want to check shadow maps, you can go to shadow depths. And basically visualize the content. I won't find it here probably. But if you find the right step in the pipeline, you should see something like this. So this is the depth of the scene, but for the given light, showing what it renders and what does it see, helping you with optimization. Okay. Lumen scene lighting. Build card update context. What is it? What is it? That looks cool. Virtual shadow map. How big is the value? Until we see anything. Maybe just the grayscale shadow map. Okay, never mind. Auto. Right. Lumen. I want to see lumen. Show it to me. Ah, this is just a clear card page index. But there's some drawing. Where's this lumen thing? Lumen scene lighting. Direct lighting. What do we see here? Lumen direct scene lighting looks like this. Doesn't tell me much, to be honest. This looks nice. Oh, this is the side of one of the objects. This is that thing right here. Right here. And this cracked thing will be that thing shown there. Okay. And the rest is probably, you know, the scene itself, the floor. But it doesn't tell me much yet. Oh, here are the colors. So look what it did. It took my objects, split them, and rendered them like that. It rendered them like that. The floor is a lot of space, but it's flat. It's gray. But this thing right here is my mesh with my logo. When did it do it actually? Let's right click on it and see pixel history if possible. Ah, history is not available. Okay. Direct lighting step. Build light tiles. Whatever. Compact light tiles, shadow map, off-screen shadows, lights. Okay, this is already something. Ah, it's the normals. And this is scene direct lighting already. Direct lighting. Nice. Oh, and this is the name of my skybox. Okay, so again, as with Nanite, tiny little quads to draw using a shader, but only where necessary. So, you know, because if triangle doesn't cover some pixels, it's just skipped. So it doesn't have to go over this huge texture. It just draws in the appropriate places. These are the tiny tiles of lumen, basically quads with material that's drawing the lumen. Okay. That looks pretty cool. Ah, so the inputs are the normal of that scene, the depth of that scene, and based on that, so it's probably height. Yeah, you can see the height of the cracked thing, cracked model. And based on that, it draws this. So direct lighting from the skybox, from the Blueberg sunrise. Okay. Actually, this Blueberg sunrise is not only the skybox, it's also the directional light, I think. Whatever. Oh, and now there's the combined lighting, already including the textures of my objects. So this blue and this red one with Techart8 logo. Nice. Okay. And where does that go later? Voxelized cards. What does it mean? Okay, that's basically it. And after that step, lumen is calculated and stored. And okay, here directional light is applied. fine. And when does it apply? Just direct lighting, yeah. When does it apply lumen? Post-processing, maybe? No. Render finish contains lumen already. So it has to be after that. Exponential height fog. Okay, this is before the fog, this is after the fog. And then when is lumen applied? Not here. Post-processing. Not here yet. Eye adaptation, bloom setup. Fine. No, sorry. So it's already there. Probably. Lumen is already there after lighting. Yeah, it has to be because it's not totally dark. I'm not sure. Because it's just not tone mapped. But stuff is already there. Here. Diffuse indirect and AO. Okay. So this is lumen reflections. And then here it's compositing of that. So that's before. Lumen lighting composited inside. And only then we have the direct lighting applied. Okay. So it's diffuse indirect and AO right here. Right here. One huge qual. This is our lumen GI. As you can see, I have to increase that range because it's HDR. Perfect, with some noise also. So yep, here's our lumen. And lumen reflections. And in the output, it's combined together and brings us this. Looks too saturated and weird because it's not tone mapped, but it will be later. The render finish. Okay, so that's it about RenderDoc. For those of you who joined later, renderdoc.org, download it. In Unreal, enable the RenderDoc plugin, okay? And then to make sense what's in there, of course you can rewatch today's stream. I will post it on Patreon. So patreon.com/degradate. As usual. This is the previous stream. And also, there was one thing. Do I have it in my bookmarks? Nope. I don't, but there was something about dissecting UE4 frame. And UE5 didn't change that much. Render. Okay, I won't find it that easily. Sorry for that. RenderDoc is also used for very nice articles. Like, for example, that one by Adrian Kulerze. Doom graphic study. So, not only showing you what's there, but he explains a lot of stuff, a lot of very interesting stuff. For example, how Doom did the frosted glass. So much recommended. Take a look into that link. Okay. And what? See you on the next stream. Next Sunday. Thanks everybody for being here today, and bye.